Okay, so let's just go through a couple quick examples and then I'll let you folks work. So I'll give you like pretty decent work day today. Tomorrow I want to show you a couple more examples, probably some time to work. And Monday we've got reserved for something different. Okay, good. So that's our through Thanksgiving. That's what we got going in here. All right. So real quick, let's review. We got a better way to write this one, right? If we're saying that y equals some function of u, where u is a function of x, right? It's implied that u is a function of x. Then y prime is just going to be f prime of u times u prime. Right? That's the easiest way to think of the chain rule. The easiest way to write it. Okay. So let's practice. Think about something like that. Well, what is this? All you got to look at is just, peel the layers from the outside in. At the outermost level, what kind of a function is it? It's a cube, right? It's a power function. So we got hand cubed, right? So the first layer of our derivative, what's the derivative of hand cubed?
3 hands squared.
3 hands squared. Right? And then what's inside? Well, right. I thought it was kind of effective yesterday. You tell me, but I thought it was kind of effective to erase stuff as we went.
Yeah.
Oh, there's something else I would do to this. Before we even start this problem, what could you do?
Move the bottom up to the top.
Well, true. You could factor a t out of the bottom, right, and cancel a t. Everybody see that? That would be a good idea. That would make things a little simpler. So inside the function, right, inside the brackets, we could write this as t over t cubed minus 4.
T squared.
T squared, you're right. Right? Everybody see that? That makes life a little simpler, right? Then when we do our derivative, we've got smaller numbers to work with. So definitely a good idea. Okay. So there's our first link in the chain, right? We did our derivative of the first layer, so we can go ahead and erase the outside layer, which is a power function. Now what's left? What kind of a function, what kind of a derivative rule would apply there for differentiating that layer? We'd have to use quotient, wouldn't we, right? So then we're multiplying by.
Is there a way that we can get out of the quotient rule using this rule?
No. You didn't have to use quotient rule or product rule. You can't avoid it, right?
So should we use the product?
I would use the quotient rule. You'd be better off using the quotient rule. So quotient rule, that's going to be what? Good, low D high. So we got low is t squared minus 4. D high is 1 minus high. What's D low?
2t.
Good, it's 2t, right? And then divided by,
D squared.
okay, good, so the bottom squared. So we're going to get t squared minus 4 squared. And we're done. There's really only 2 layers to that. It's just that it kind of complicates things with the quotient rule. So then let's work on just getting this written in a simple form, right? There's not a lot of work to do here. But like, what could we do? What's our denominator going to be?
Not something to do on that section.
T to the 4.
T squared minus 4 cubed.
No. You gotta be careful. This is a little tricky because don't forget, look, I got an exponent up here, right? So I've got to distribute that. I've got to distribute that to both the numerator and the denominator. So if I end up with a t squared minus 4 squared on the bottom here and a t minus 4 squared on the bottom here, so what do I get? To the fourth, yeah. Okay, on the top, here, what contributions do I get here? Well, I'm going to get a 3 times a t squared from that part, right? So there's, from there, and then up here I can probably do some simplification. So what am I going to get? Up here, if I just combine like terms, this is pretty simple, right? I'm going to get t squared minus 4 minus 2t squared. So negative t squared minus 4, okay? What can we do with that? Well, one thing I would definitely do, and this is, I strongly encourage you to do this, this really helps. Let's factor the negative out. So we'll put the negative out in front with the 3, right? Which is going to make that what then? T squared plus 4. And we're done. Right, yes, sir.
Would you be able to plug that in, Jack, and some of that?
Say it again.
Could I plug that and do that and some of that, or yeah?
Plug this in?
Yeah.
Oh, that would be fun. Yeah, yeah. I've checked him. It does a pretty good job of accepting reasonable algebraic equivalent expressions. Honestly, it might even, I wouldn't, you're going to have to get used to simplifying it like that. It's not enough, probably, right? And we are going to do, we're coming up on a part where, like, this is a big enough topic. It kind of brings a lot of stuff together. I probably want to do like an open-ended test, paper and pencil test on this one too, where I'm going to give you just a couple problems, but I want to see your work on this and make, see what you're doing. Okay. But that's, yeah, so would it be different? I think what Kirk's getting at is, what if you distributed the t squared? Would it make, no, it'd be fine. It'd be fine. Yeah. It's not like there's one right answer. That's a pretty good answer because you want it factored on the top and bottom, but just in a pretty simple form. Questions on that? Oh my goodness. Shoelace got all tangled up. Okay, what about this guy? Everybody see that? The one I wanted? We do, oh, never mind. Yeah, that one. Okay, what about that? Yeah, we could rewrite that, but we just know radicals are 1/2 powers, right?
Yes.
So what's the outer layer here? Okay, so I get something to the 1/2, right? So if I'm going to write this down, let's just write it, and we'll erase as we go. So what's the derivative of hand to the 1/2? 1/2. Hand to the negative 1/2. So same thing as 1/2 times the square root of hand, right? So the first layer then is going to be that. 1/2 times the square root of all that stuff, right? Yeah, you bet. Okay, and we can erase, we did the first layer. So we can erase, that's fine. Okay, so we erase the square root. Now we got to take the derivative of hand. What's inside? So what's that going to be?
That would be 7 plus
7 plus derivative of that.
That square root.
Okay, now that's, so these can get a little complicated there too, because this term is done, but when I'm differentiating this other term, of the, you know, what we originally called hand, it's requires the chain rule, right? It's a composition also, right? So this guy's done, but this guy's, we're gonna have to continue with a little bit. So once again, we've taken the square root of hand, right? And so we already know that's gonna be 1/2 times the square root of hand. Oops. Right, and then just that term right there, we gotta keep going. We gotta go another layer with that one, right? So now, this guy's gone. That's what's inside, right? What's the derivative of that? Well, the derivative of 8 is 0, right? And then the derivative of, I don't know what we call that. It's, I don't know, it's just, I mean, we're getting smaller pieces, but we get the derivative of something, square root of something, and once again, that's just 1/2 times the square root of something. So there's my 1/2 times the square root of 5 minus t, and then finally, we're inside that radical, and what's the derivative of 5 minus t? Derivative of that. Derivative of 5 is 0. Derivative of negative t is -1. Right? So this part, you know, we required some more extra chain rule stuff just to differentiate the other term inside that first radical, right? And so what can we do? I mean, I guess we could, there's not much. I mean, really, we could just combine that 2 and that 2 for our final answer. This is what they had. Does that make sense? There's the outside stuff, right? That's what's in red. Here's, kind of link some of this up. There's our 7. And then we put the minus, right? Put the minus out front. How did we get the 4? Well, 2 times 2. And then I've got these separate, I've got this radical times that radical. So there's not that much cleaning up to do there, right? Can you see how that worked? Okay. That's a pretty hard one. I mean, that was like, in this, I looked through these college texts, and in the college text, of the 150 problems for chain rule, that was like the second to the last one, after the hardest ones at the end. So that's considered to be a pretty hard problem. All right, work. Get questions answered.